since last year. So this course is very difficult. It shows that very less people are, able to qualify. Is that true?
So actually, I haven't appeared in the exam of this course, so I can't really comment. But generally, what happens is that questions are quite similar to whatever comes in the assignments. So you can
The
expect.
thing is,
Huh?
but the thing is that like whatever the question is giving in the assignment, it is quite similar to that only, now,
Yeah,
or very hard questions will come.
yeah, like you can expect similar difficulty that you are facing in the assignments.
What?
Uh, if you are having assignments, right, weekly assignments in the course.
Yes, yes,
Yeah, so
yes.
in the exam also, you will get similar kind of questions.
And like only MCQ will be there or like MSQ will be
Yeah,
there?
MCQ and MSQ.
Both.
Yeah,
Hello.
yeah, both. Can you hear
So
me?
there will be any
Huh.
is that since less like that,
Uh,
very less MSQ or like that also.
so that is not certain. Anything can come.
And like if we are going through lecture and then we are understanding that is that enough or we have to follow any other resources because the graph that tradition is very hard. It is showing that very less people are able to qualify this exam. And actually, uh, our college that I'm from NIT Warangal and this year they have like fixed like our credit is like depend on that NPTEL.
Okay,
So
okay, okay.
that's why I'm little so
Yeah.
that's why I want to ask.
So generally, if you understand all the lectures, and then
Huh.
if you are able to solve the assignments, you should have you would have no difficulty, okay, in the exam. But you can also follow the book. There is a book, suggested book on this course, so you can also follow that. So
So is that PDF available here? Because only transcript is there, no? Or in book also that transcript is there.
okay, I'll show you the book link.
Yeah, please.
Yes.
And the that content remains same, no? That whatever the transcript is, uploaded for the last year, past to past last year. So that is same only, no? For
Yes, yes,
video also.
yes, yes. There's some.
Oh, okay.
So I'll just show you the uh, book. So if you go there, uh, I think my
Mm-hmm.
screen is visible. So if you go to the
Yeah,
course
yeah.
website, okay, here is the book.
Mm-hmm.
So books and references. The first one, the elements of statistical learning. So this is freely available online. So
Okay.
if you just can search it, so you will get the book here. Okay, this is the link for the book.
So here, like in doubt session, you are discussing the assignment or any other
Yeah,
questions?
I'm discussing the assignment of the today I'll discuss the assignment of week 8 from the previous year questions. So previous year,
Week,
yeah.
what you have said?
So today I'll discuss about this one, like gradient boosting random forest, this nib base, and obviously you have the assignment for week 8, right? So because of that,
Yeah.
I will solve the assignments from the previous year.
Okay, okay.
Yeah.
And like, is there anything site or anything where previous year questions are available?
Not that I'm aware of.
Like, can you get and you can share with us? It's very helpful for us. The way, like, we have one idea that how the questions will be asked.
Okay, so in the exam, I don't have any access to the questions from the exam, but I have access to the assignments. And in these slides, I'll provide the link to the slides also. So in the slides, you can
Yeah,
get the
sure.
assignment. Yeah,
Yeah,
but
sure, sure. Like last, because this course have started since 2, 3 years back, right?
right,
Hello?
yeah, yeah, right,
Yeah, so it's very helpful if you share the previous year assignment also.
yeah. So yeah, I'll share. So I'll share the slide link,
Okay.
and you can find it there.
Thank you so much. Thank
Okay,
you.
welcome. Okay, so let's get started. I am Baban Gain and I'll discuss about the assignments. Mostly I'll ask you, I'll show you the question and you can write the answer in the chat box here. Here is the chat box, so you can write your answer here and then I'll discuss the solution. Okay. So this is the first question. You have the following graphical model and you have multiple nodes and edges, and the question is that you don't know value of any of the variable, and from this graph what can you say, which pair of the nodes are independent, they are not depending upon each other. About which pair of nodes can you say? So are C and D are like independent, are C and E are independent? What do you think? You can write in the comment section. So C is a child of A and B, and D is a child of B, and E is a child of C. So based on this, which nodes are not dependent upon each other, directly or indirectly? Okay, so A, B are independent. Okay, so A and B are independent. That's what you are saying. So can you give a reason why do you think A and B are independent? Anyone can write, or you
Because
can, yeah,
yeah, we can speak or we
yeah,
have to
sure,
write.
you can speak.
The thing is that can you share that screen
Yes, yes,
question?
sure.
Yeah, if you think about the C, C is depends on A and B. Like as C is dependent on A and B is also
Okay.
come. And but if you look about the D, again B is depending on D because B have the child to C and D. Again, if you look about the E, it is coming through C. But if you look about A and B, it is independent as they are giving C. But so that's my
Yeah,
observation.
right. So you are totally right. So this is the correct answer, A and B. So basically, uh, node A and node B does not have any parent. So obviously they do not have any common parent, right? So that is why their A is not dependent upon B and B is also not dependent upon A. So this is the correct answer. Okay. So if you have any doubts at any point, you can ask. I'll move on to the next question.
Sir,
Yeah.
can you tell about E and D? Is
Okay.
there any relation between E and
Okay,
D? Yes.
so here is the B and we have D here, right? So actually D is dependent upon B because D is the parent, like a child of the node B. So they are not really independent upon of each other.
No, sir. E for elephant. E and D.
E and D, right? E
Yes,
and
yes.
D. Okay, so E, parent of E is C and parent of C is B. Okay, and parent of D is B. So we have a common ancestor or common parent, right? B is the common parent, even though B is the direct parent of D and B is the parent of E, but we have a common ancestor, right? So that is why they are not independent.
Okay, sir.
Yeah. So this is a simple
Please explain once again.
what one? Which one? Hello.
Sir, actually, she is asking about E and D again. Right?
Okay, E and D. Okay, so if you go to the parent of E, what is the parent of E? And the parent of E is C, right? And what is the parent of C? A and B. So ultimately, if we take the number, what are the all parents of node E? A, C, and B. All three are parents somehow, like parent, parent of parent. If we just take the set A, B, C, all of them are parent of E. If you take parent of D, B is the parent, right? So ABC is a set and B is another set. So there is overlap, right? So B is common in the both the sets, right? So this is not really dependent upon this because because both are coming from B directly or indirectly. So this and this are both dependent upon this, therefore this and this are not independent. So does it make sense?
Okay, sir.
So I'll go to the next question, which is a very simple probability question. I hope you have solved this earlier also. So there is a man and he kind of speaks truth as well as sometimes lies. So two out of three times he will speak the truth, but 1 out of 3 times he will lie. And suppose you are playing a Ludo and he has thrown a die, okay, and he is reporting that the number is 4, okay, and but you don't know because sometimes he speaks true, sometimes he speaks false, okay. So the question is find the probability that the number that actually obtained is 4. So he is telling that he obtained 4, but he sometimes lie, he sometimes speaks the truth given the probabilities. So you have to find that he is actually obtained 4. So can you calculate the question? So any intuition how do you solve that? So this is basically a very simple probability question. 2 by 3, okay. Any other solution? I don't know actually the answer right now. I'm not sure what could be the answer. We'll solve this together, but is there any answer, any alternative answer to this, or anyone else think this is the answer 2 by 3? Okay, now I remember 2 by 3 is not the correct answer. Any more solution to this question? Okay, I will move forward and show a few steps, then I will ask you again. So there are two events here. Event 1 is that we are actually obtaining 4, okay, and event B is that the man is saying 4 is obtained. So these two are the events that we are talking about, that given that man is saying that we have obtained 4, what is the probability that 4 is actually obtained? So how can we write this? P of A given B, right? Because we have mentioned, right, that the number obtained is 4. So the man is showing that, man is telling that the number actually obtained is 4. So P of A given B. So that is what we have to find. So can you find this? So what is the formula for conditional probability?
P of A into P of B by A divided by P of.
Right.
We can say, yeah,
Yes.
this is.
So this is the formula. So P of B given A and P of into P of A, okay, divided by this, and P of B given not A into P of not A. So can you find this? So what is P of B given A? Can anyone tell this from this question?
2 by 3, no?
P of B. So man reports 4 is obtained. Given 4 is obtained is 2 by 3, right? And what is the P of A?
1 by 6.
Right. And what is the P? This one P of B given not A,
1 minus 2 by 3, that is 1 by 3.
right? And this one P of not A,
5 by 6.
right? So this is how we obtain. So basically, P of A is 1 by 6. So basically, if you throw a die, what is the probability that you will get a 4? So there are 6 options and 4 is only one option. So this is 1 by 6, and P of not getting A. So 1, 2, 3, 5, 6. The probability of getting those is 5 by 6, right? So this is what we got this part. Then P of B given A. So what is the probability that person will say that 4 is obtained given the 4 has actually obtained? So that is 2 by 3, right? Because he speaks truth 2 out of 3 times. And what is the probability that he will say that 4 has been obtained even though it has not been obtained? So that is 1 by 3, because in 1/3 of the cases he might lie. So if you just put this into the equation, you will get the answer. So basically, P of B given A is 2 by 3 and P of A is 1 by 6. Same thing we copy here, and P of B given not A is 1 by 3 into P of not A is 5 by 6. So we have just copy pasted these equations here, right? So if you calculate, 2 into 1 is 2 and 3 into 6 is 18. 2 into 1 is 2 and 3 into 6 is 18, and 5 into 1 is 5 and 3 into 6 is equal to 18. Okay. So 18 will get cancelled, and 2 divided by 2 plus 5 is 7. So 2 by 7 is the right answer. So if you have any doubts on this question, at any point you can ask. Yeah, 2 by 7 is the answer. Okay. So if it is clear to everyone, I will go to the next question. So yeah, when in this course, like there are week 0, in week 0 probability and those concepts are covered. So in exams also these kind of basic probability type questions and basic linear algebra type question can come. Okay. So again there is a probability question, and you might also have saw this earlier also. So basically there are two cards, like you have a bunch of cards, basically 52 cards, and you are actually taking the cards away from that without replacement. So basically you are taking the first card, and without like putting it back, you are taking another card. Okay. So the question is that what is the probability of drawing a 5 and then an ace? So basically in the first attempt, when you are first pulling out a card, what is the probability of getting 5, and then in the second card, what is the probability of getting an ace? So basically they have to be in the same order, not that at first you will get ace and in the second attempt you will get 5, not that. At first you have to get 5 and then you have to get ace. So in that order, what is the combined probability?
So D option, 4 by 663.
Okay, so can you explain why?
5 will be, we can have 4 number of 5, 4 by 52 into, then we have 4 number of ace divided by 51.
Okay, why
Actually, these
51?
are independent events. So
Okay, Okay, but initially it was 52, but why are you saying 51? Can you explain a little bit?
Without replacement, no, sir.
Yeah, right,
Number
right.
of cards.
Exactly. So, yeah, you are absolutely right. So, basically, let's take one by one. So, at first, we'll have to pick a card and with number 5. Okay. So, what happens in the card is that you have 13 numbers and like king ace and things like that. So, 13 different numbers and 4 colors. Okay. So, how many fives you have in the card? You have phone number of fives. Similarly, phone number of 2, phone number 3, like that. So, the probability of picking 5 from 52 cards is 4 divided by 52, because there are 4 cards having 5 written on them. So, it is 4 divided by 52 equal to 1 by 13. Okay. And out of the so actually suppose in the first try you have picked the 5, right. So, you have 51 cards remaining, and out of the 51 cards, and what is the probability that you will pick B, right. So, uh, B means here you, what is the probability of picking S. So, S is also present 4 times in the whole card. Okay. So, here also the probability is 4 divided by 51 because you have already picked one card earlier and you haven't put that card in the deck back. Okay. So, probability of picking the 5 at first is 1 by 13, and probability of picking the ace in the second attempt is 4 by 51. So, because they are independent, so P of AB equal to P of A into P of B given A. So, that is 1 by 13 into 4 by 51. So, 1 by 13 is P of A and P of B is 4 by 51. So, if you calculate that, 4 into 1 is 4 and 13 into 51 is 663. So, this is the probability of picking a 5 and an ace in like that order. So, at first you have to pick an 5 and then you have to pick ace. So, that is the probability. So, is it clear? Okay. Yeah, denominator is P of B, where? Yeah, in the previous question. Okay. So, I will go to the next question. So, you have a Bayesian network and you have only outgoing edges. So, outgoing edges means suppose, okay, let me draw here. I hope it is clear to everyone what does outgoing nodes mean. So, outgoing nodes mean only outgoing nodes means like only edges are going from that, not coming to that node. So, like if that happens, which of the following is true? So, you have this, the variable is conditionally dependent of other variable, a variable is dependent on its sibling, and we cannot really say certainly that what is the case, what is happening here. So, let me draw a diagram for this. So, you have this node, okay, let us say it is A, and there are many other nodes B, C, D. So, the question is this is A is just outgoing node, right? Question is A is with only outgoing edges. So, from B you have this, maybe this, but you don't have this kind of edges. Okay, this kind of edges are not there. So, what can you say? Okay, so there is no answer to this question.
Can you show the questions?
Yes, yes. So first option is that it is conditionally dependent of other variable, sorry, conditionally independent of other variable, and then second option is that it is dependent on its sibling, and third one is that we cannot really say what is the, like it is uncertain.
It should be A, sir.
Right. So I think it is kind of obvious, but can you still explain what is the intuition?
A is one level up about this B, C, and D. What you draw now.
Right.
Parent. It is a parent.
Right. So
So, independent.
it does not have any incoming edges, so it is not really a child of any other node. Okay. So basically, it is not dependent upon other node, but they are dependent upon A. C is dependent upon A, but A is not dependent upon C or any other node because there are no incoming edges. So A is the correct answer here. Okay. Okay. Next question. So which one? So you have three options, and which one is more likely to overfit? First one is ADA boost, and second one is gradient boost, and third option is that both are equally likely. So if you have any data and you are using these two methods, then we cannot really say that this one is more, have more chances to overfit. So which one is correct? So ADA boost is covered in the week 7 last lecture, and gradient boost is covered in week 8 first lecture. ADA boost is more likely. Okay, this is one answer. Fine. Is there any other answer anyone would like to say? Right. So ADA boost is actually a correct answer. So basically what happens is that in the ADA boost we use exponential loss, right, and in the gradient boost we use like least square loss. So what happens in ADA boost is that because of exponential loss, whenever there is an outlier, we penalize it too much. So whenever there is an outlier, we try very hard to not misclassify it, to kind of correctly classify it. Okay. So in overfitting, what happens that even the outliers are get memorized, right? So in the ADA boost that actually happens because we treat our outliers very harshly. Okay. But in the gradient boost, because of least square loss, we do not give that much priority compared to the ADA boost in gradient boost. That is why, even if there are some outliers, maybe it is not that difficult to ignore in the gradient boost. So that do not lead to overfitting as much as ADA boost does. Okay, so this is a numerical question. You have different type of phones. We have budget phone, mid-range phone, and high-end phone, and basically this is how many of them having single SIM, okay, and is it 5G compatible, and does the phone have an NFC? So these four are the parameters. Okay. So basically what we have to find is that we have a new phone which is having 2 SIM card and it has NFC, but it does not have 5G. Okay. So what is the probability? Is it is it budget phone? Is it mid range? Is it high end? So you have to find this. You have this data, and from this data you have to find that given a new phone with dual SIM, NFC, but no 5G, what is the probability that this is a budget phone, what is the probability that this is a mid range phone, and what is the probability that this is high end phone. So total you have 20 budget phone and 30 mid-range phones and 20 high-end phone. So basically what we are saying that out of budget phone, 50 phones have single SIM and 5 phones have dual SIM. Out of 20,
How is it total is 30? How it is 30? 20, 20, 15.
okay, okay.
So how it is?
So yeah, so consider that some phone have single SIM as well as 5G as well as NFC. That is possible, right? One phone can have multiple features.
Okay.
Yeah. So basically we are showing that how many phones have single SIM. So basically here 20 means 20 phones have single SIM and 10 phones have dual SIM out of 30. 20 phones have 5G and 10 phones have 4G. And here 15 phones have NFC and 15 phone doesn't have NFC. So that is how you should interpret this. So any intuition how to solve this? We have to find P of budget given we have dual SIM. So dual
Sir,
SIM.
here one SIM only is given, no? How two SIM will come? Dual SIM, no
Okay.
data is given. No?
Okay, so here 15 of them are single SIM. So whatever remaining 5 they are dual SIM. Okay, so here 2 SIM means not single SIM.
Which five, sir? Out of
So
five
you
from where,
have
sir?
total 20 phones, okay, here, and you
That
have
is including all the columns, no?
no,
No.
that is not including
Okay.
all the columns. So here you can see 20, 20, 15. So that is not 30, but we are saying total 30. So basically we are saying that we have 20 budget phone, and out of 20, 15 of them are having single SIM, and 5 of them are having dual SIM or triple SIM, whatever, like not single SIM. So we have two classes here. 15 of them are single SIM and 5 of them are dual SIM, like 2 SIM. 5G compatibility, 5 of them are having 5G and 15 of them are having let's say 4G. NFC, none of them have NFC, 20 of them are like not having NFC. Similarly, if you take the example of high end, okay, all of them are 15, but total is 20. So consider is that 15 of them are having single SIM, 5 of them are having dual SIM, 15 of them are having 5G, 5 of them are having 4G, and 15 of them are having let's say NFC, but 5 of them do not have NFC, and that is the distribution here. So like every column will kind of add up to 20. Okay, little by little I will move on to the answer. So this is the data we have here, and we have a phone with 2 SIM card and NFC, but no 5G. Okay, that is our constraint. So what is the P of class? P of class is x1, x2, x3. So x1, x2, x3 are the given features. So how to estimate that? we can estimate that by this formula. So, what is the P of class? P of class here means budget, mid range and high range, right. So, P of class into P of x1 class. So, x1 means single SIM given budget, x2 here means 5G compatibility given budget, and x3 uh, x3 is like NFC yes or no given budget. So, can you find what is the probability of budget phone given
1 by 4.
mhm.
1 by 4.
Okay. How do you get the number?
Sir, actually, 5 by 20. Because 5G compatibility is it's told it should not be there. Only NFC is 0. So only 5 by 20 will come.
But there are total 70 phones, right? So 5
Probability of class is 2 by 7, no?
uh, probability of classes might be 2 by 7 if you don't consider this, right. So, if you just take a phone at random, the probability of budget will be 2 by 7, but you have this information, right, that we have 2 SIM card, we have NFC, we do not have 5G compatibility. So, depending upon that condition, what will be the probability?
1 by 14.
Okay, so how do you get the number?
Total equal to 20 plus 30 plus 20 by 5. It's sorry 5 by 17. So it is 1 by 14 because total is 17. No?
So, total is
Sir,
7 by
here
7. Yeah, what?
one doubt is the NFC is 0, no? So 0 we cannot multiply it. Everything will become 0, no?
Yes, become 0 only.
Okay.
Because we have to consider NFC and the NFC value is 0.
Okay. But we are saying that we do not have any NFC. Sorry, yeah, it has NFC, right?
Yes, sir. It is happy.
Okay. So, this is how we will get it. Okay, you are right that if we do not have a NFC
Yeah,
value
0
0, it will be
only.
0. So, we have to find like this P of budget. So, at first we will calculate the for this class budget class. So, this is single SIM. So, we are saying that we have 2 SIM, right, dual SIM. So, that condition is does not satisfy, right. So, we are saying not single SIM, because this column is for single SIM, we do not have a single SIM, we have dual SIM. So, not a SIM. Then we have not 5G, because we are saying no 5G compatibility, and we are saying we have NFC. Okay. So, how to estimate that? At first we have to find what is the probability of budget. So, if we take randomly, what is the probability? 20 by 70, right. Total 70 phones are there and we have 20 phones in budget section. So, P of class is 20 by 70. Okay. Then P of x1 given class. So, x1 is what? S SIM. So, what is the chance that, what is the probability that having single SIM, having a dual SIM in the budget section, what is the probability? So, 5 phones have 15 phones have single SIM and 5 phones have dual SIM, right. So, out of 20 phones, 5 phones have dual SIM. So, the probability is 5 by 20. Okay. Again, if we go to the 5G, then out of 20 phones, only 5 of them have 5G, but we are seeing that we do not have 5G. So, what are the chances of that? 15 of them do not have 5G and we are saying that we do not have 5G. So, the chances is 15 by 20. And NFC, we are saying that we have NFC, but in this case they are saying that none of the phones have NFC. So, here the chances are 0 by 12. So, if you calculate the number, because there is a 0 term here, everything will come out to be 0. So, I hope it is clear to everyone. If not, I can explain again. So, if it is clear to everyone, then can you solve the mid-range value? What will be the mid-range value for the same question?
1 by 42.
1 by 42.
1
Okay.
by 42.
How can you say?
Yeah, like first of all, 30 into 70, the class that after that you don't have to consider single sim. So 10 by 30, 20 minus 20 single sim. So 30 minus 20, 10 by 30 into again not considered to be 5G. Again 30 minus 20, 10 by 30 into NFC is 15. So 15 by 30, 1 by 2. So that is 1 by 42.
Okay, so 15 by 30 is 1 by 2. So this is the
Yeah,
answer.
only this one only.
Okay,
Yeah, 1 by 42.
yeah, yeah, right,
Same.
right, yeah. So yeah, this is the just the basic calculation. You got 30 phones here, total 70 phones. So P of mid range without considering anything is 30 by 70, and out of 30 there are 10 mobiles with dual sim capability. So it is 10 by 30. Out of 30 phones you have 10 mobiles with 5G like not having 5G compatibility, because 20 have 5G, so 10 does not have 5G. So this is again 10 by 30. And then in NFC you have 15-15. So 15 of them have NFC and 15 of them does not have NFC. So here again 15 by 30. So if you calculate the number, it is 0.02. Okay. So I got an answer here. So someone is saying mid, then budget, then high. So we have calculated right here that budget probability of budget phone is 0. So that is going to be the lowest, not the middle one. Okay, budget will be the lowest. Then obviously, like if the budget is the lowest, then high will be the next. Anyway, let's go to the calculation for high. So we just take the same calculation. There are 20 high-end phones, so 20 by 70. Out of them, 5 of them do not have single SIM. So basically, 5 of them have dual SIM. So 5 by 20. 5 of them have NFC capability. So 5 by 20, and like only like 15 of them does not have any 5G compatibility. Okay. So basically yeah, so single SIM, this is clear, 5 by 20 because it is dual SIM. Then not 5G. So how many of them do not have 5G? 5 of them do not have 5G, right? Because here 15 of them have 5G, so 5 of them do not have 5G. So it is 5 by 20. And NFC, 15 of them have NFC, and our mobile also having NFC. So here it is 0.0134. Okay. So this one is highest, mid range is highest, then we have high end, and then we have the budget phone. Okay. So that will be the like order, mid range, high end, then budget. So we will move to the next question, but if you have any doubt on the previous question, please feel free to ask. Right. Okay. So let's go to the next question. So you have this data set. Yeah, it is a kind of large data set, but anyway, so you have the outlook, you have temperature, humidity, and is it windy. These are the parameters, and based on that you have to decide that there is a child, and will he or she play, will he or she go to play outside given this. So what happens is that if it is windy, if it is sunny, then most of the time he is not playing. If the temperature is very high, most of the time he is not playing. Similarly, there are other parameters also. So you are given that today it is sunny, the temperature is 66 and humidity is 90 and it is windy. So, there is a wind and you have to use naive Bayes method and you have to find that will the boy play today, will the boy or girl play today, depending upon these parameters. So, yeah, consider all of them are independent. Okay. So, even though like that is not really the case, generally if the temperature is high, generally we can consider it is sunny, but for sake of calculation just consider that all of them are independent. Okay.
Can you please zoom that
Yeah,
picture?
sure. Okay. So, let me do one thing. Okay, just forget all variables. Can you say the like probability of playing? Just consider that there are no temperature part, humidity or windy part. Like those column does not exist. Suppose
10 by 14.
okay, 10 by 14.
Yes.
Okay. Okay. So we'll see is it correct, but okay. For now, can you say? Can anyone say that suppose these columns does not exist? We are just saying that will the boy or girl play based on the outlook. Okay, and suppose the outlook is sunny. So, what is the probability of the boy or girl playing?
Can you repeat your question?
Suppose like we do not have these columns temperature, humidity, windy. We just have the outlook column, and we are saying that what is the probability of playing given outlook equal to sunny. So, if there is sun,
0.4, 2 by 5.
okay,
Twice only he goes out when it is, you see
sunny,
the last column. Two
right,
times only he is going
Yeah.
out of 3 times.
right. So, there are 1, 2,
2 by 5.
yeah,
Yeah, 5 sunny again.
right. So, you have let us say 5 rows where it is sunny. So, basically 1, 2, 3, 4, 5. So, 5 rows where it is sunny, and here the child is not playing, here also not playing, here not playing, here playing and here playing. So, only 2 out of 5 times and the child is playing. So, okay, that is for one variable. Let us go for multiple variables. So, basically we have to find that uh, so basically here is the x is the data point, and in x we have outlook equal to sunny, temperature equal to 66 and humidity equal to 90 and wind equal to 2. These are the data we have, and we have to find what we have to find that the chances the child will not play. So, this is we have to find out. Okay. So, basically p of x given no. So, we have to find that what is the given the child is not playing, what is the probability of this happening, outlook equal to sunny, like this condition satisfying, what is the chances, into what is the chances of the kid not playing. Okay. So, that is how we find p of not playing given x, right. P of no given x equal to this formula, p of x given no into p of no, right. So, this is how we break it. So, p of x given no, right. So, we have to break it like this. There are 4 variables here. So, P of sunny given no. So given the child is not playing, what is the probability of it is a sunny day? Okay. Then given the child is not playing, what is the probability of the temperature equal to 66? Again, given the probability is no, like given the child is not playing, what is the probability that humidity is 0.90, like humidity is 90, and then what is the probability that it is a windy day given the child is not playing. So these are the four things that we have to consider into what is the probability that child is not playing. So like we have broken P of x given no to these four parts 1, 2, 3, 4, because there are 4 variables here, and finally we multiplied it into P of no. Okay. So what is the probability of not playing? So if you just calculate this, okay, P of sunny given no. So how many of no are there? 1, 2, 3, 4, 5. So 5 no's are there. Okay. And how many of them are sunny? 1, 2. This is not sunny. This is sunny. Okay. And this is rainy. So not sunny. So 1, 2, 3. 3 of them are sunny, right? So you have to the probability of sunny given the child is not playing is 3 by 5. Okay. Then given the child is not playing, what is the probability of a temperature equal to 66? Okay. So yeah. So again you have to consider this. Okay. No here out of 5, and you have temperature. Okay. So here temperature, you know, there
Here, are you seeing the temperature of sunny here?
what
Or like that is not 66 like that?
can you repeat?
No, no, I'm asking that how you are seeing this, like temperature is equals to 66 for sunny only.
No, we are not seeing that actually. We are treating that independently. Okay, so sun is independent,
No.
temperature is independent. Okay,
So how you are calculating this?
which one?
That 0.027.
Okay, yeah, I'll come to that. So temperature, you can see here. Okay, so basically, go to the no here. Okay, these no, 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 and no. 5 no's are there. Okay, so 85, 80, 65, and 72, and here we have 71. Okay. So okay, let me find it out. So okay, so you have to consider this, assume that continuous features are represented as Gaussian distribution. So basically in Gaussian distribution what happens is that mean is 0 and variance is 1, right? Right. Okay, so whatever. So basically we have to find it that what is the mean here, mean of the temperature.
E73 by 5, 70.
74.6.
Are you taking for all of them or only where sun like play equal to no?
Play equals to no.
Okay, so what is the average?
74.6.
Okay, and can you calculate the standard deviation? XML source to do this.
And in exam, will they provide scientific calculator?
Yes.
Okay.
So you will be getting a calculator like this. This kind of calculator. Okay. Yeah, this one. So it will be like on-screen calculator. Okay. Anyway, so can you find the standard deviation of the data out of the 5 where play equal to no? Okay, let's calculate then. Okay, so what are the data points? 85, 80, 65, 72 and another one. Okay, 85, 80, 65, 72, 71. Okay, mean is 74.6 and variance is 49.84 and standard deviation is this 7.05. Okay. So what is the formula for Gaussian distribution? P of x equal to this one, right? 1 by root over 2 pi e to the power negative x square divided by 2, right? So if you put the value yeah 7.05, right? Okay, just wait a minute. Okay, so basically, what you have to do is that we have the formula for Gaussian distribution. Okay, and you have the mean and variance. Okay, let me go ahead. Okay, so you have the mean here, and variance was, I guess, 7.09, I guess, right? Yeah, 7.06 kind of. Yeah, you have variance of 7.06. Okay, so in the Gaussian distribution, if you so it is kind of like let's say we are plotting like this. Okay, and uh, the values in the middle has very high probability, like the graph is like this, and here the values having very, so if the mean temperature is 74.6, so if the actual temperature is near to 74.6, it will have very high probability, and here it will have very low probability, right? So with mean and variance equal to this, you can put this equation into the formula for Gaussian distribution. Okay, and then the resultant will be this, like 0.02 or 7. So I am just trying to find the equation, but anyway, you can do this. So yeah, this is the kind of diagram. Okay, so when this is 74.6 or nearby, so probability will be very high, otherwise it will be like near. Okay, so the much if it is much away from the average, then like probability will be lower. Okay. Okay. So similarly, like okay, 1 minute. Yeah. So yeah, this formula is given here for like continuous variables. Okay, you can also this is discrete here, so you can also find that. Okay, and you can like just put the values in mean and variance there, and you can find that. Okay. Similarly for humidity also, like you can find this. You have to only consider the no part. Okay, and here you will get 0.03. Okay, then whenever you having no, so out of say 5 times, okay, you are having window how many times? 1, 2, no sorry, this one 2, and when place no uh, one time only, 2 time, and it is true here. So yeah, sorry, we have to calculate it if it is window, right? So we have to find if it is true. So here 1 time, 2 time, 3 time. Okay, 3 by 5. And what is the probability? So like what is p of no? P of no is there are total 14 data points and we have 5 nodes, right? So 5 by 14. So if we multiply all of these, then we will get this value 0.0001367. Okay. Yeah, this can be solved from Z table, but I'm not really sure. Yeah, yeah, Z table it can be solved, but that may not be always available to you. But yeah, it can be done. Okay, so I'll go to the next question. So if you are having the scientific calculator, I think like you can easily do this. Okay, you'll have the scientific calculator.
Please tell the probability of temperature equal to 66. How we got this answer.
Okay, so I am not really getting the formula for calculation, but what happens is that this is the suppose distribution, okay, and this is the mean, and you have like a standard deviation here, okay. So here the probability is the highest, and here the the much you are away from this, the probability is lower, okay. So let me try to find it anyway, okay. What is the distribution question, right? Okay. Yeah. Okay, so yeah, you have to find the z score first, okay. So z score is this, so x is the data point, okay, and mu is the mean, and sigma is the population standard deviation. So all three we have already have there, right. So data points you have all the 5 1, and mean temperature you have, variance you have, okay. So then okay, so z score you have to calculate by this, okay. So x is the data point. So suppose in this case what are we trying to find out when temperature is 66, right. So it will be like 66 minus the mean temperature is 74.6, okay, and then you have the standard deviation, which is standard deviation is sorry, variance is not this, right. We calculated earlier. This is standard deviation, right. This is standard deviation. Okay, so this will be the z score, okay. Let's find this out.
Minus 1.22.
What?
Minus 1.218.
Yeah, minus 1.218. So this is the z score that we are getting.
Sir, the answer is not matching with this.
Okay, okay. Then we have to look up in the table, right?
Minus table. This is positive, so negative table will be there.
Yeah.
Let's go.
Okay, okay, okay. So you have to kind of also normalize the data, okay. So then only like you can find out. So here we have instead of say here what happens in this is that you have to make it like mean equal to 0 and standard deviation equal to 1, that kind of thing. So basically you have to kind of so suppose okay, so you have mean temperature equal to 74.6, right, and what are the individual data points? 85, then 80 and 65 and 72 and 71, right. These are the data points, and you have to kind of somehow, so this is the average, right, and you have to somehow make the average 0. How can I do this? You can subtract everything by 74.6, right. So you can do this way, it's like 85 minus 74.6, this is one data point. Then we have 80 minus 74.6, so this is the if we divide them in, and then like if you do the same for standard deviation, okay, by the new values, then I guess like you will get some positive z value, okay, and you can calculate it from there. So it will be kind of a long calculation, but and like this is the way. So generally the step is that you kind of normalize it so that it is kind of mean is 0, okay, and then you divide it by that. So basically you first take the mean, you subtract the mean, and then take the standard deviation whatever it will come, and then you perform this operation, okay. Your your value minus that one, 74.6 is the average, okay, and divided by the standard deviation, and you will get a value, and from that if you go to the z, you can find the actual value, okay. So yeah, I'm skipping this because this is kind of a very long, but if you know the formula for the distribution, here it is Gaussian distribution, then it is 12 from the z table. So this is another question. So you have a sentence, the ball won the race to the boundary, okay. So this is the test example, and you have to find that this sentence is belonging to the class cricket, okay. So basically here you have kind of a classifier where you are building a classifier, and basically you are saying that you have some data, and you have supposed you are using NAIP based model, okay, and the only issue is that you may not have all the words, okay. So basically given this sentence, you have to find P of cricket given this sentence. So you are kind of building a classifier, you have to classify what is the probability of this sentence being belonging to the class cricket, okay. So what can be the issue? So assuming that you are using word frequency to estimate all the probabilities. So first option is that there will be no problem, and the probability will be equal to 0, like probability will be equal to 1. Another problem could be that if you word, there can be many words in the this sentence which is not which does not appear in the data set, which you use to train to build your model, NAIP based model, okay. So that can be an issue. Another is that same word, so suppose ball or won or the race, these words can appear multiple times instead of one time in the data, and that can cause issue. And last option is none of this. E. So not really correct.
Sir, it should be C maybe.
Okay,
One of these.
that is also not correct. So only option left is option B, and option B is correct. So basically in NAIP base, what do we do is that we calculate based on the word frequencies, right? So frequency of the ball, the like then 1. Okay, so it is very unlikely that their probability will be equal to 1. It cannot be, right, because the probability of the will not be uh, based on the like quad frequency. There is a chance that it will be probability equal of cricket equal to 1 only when the is present, only when there is cricket class. Ball is also present when there is cricket class. Okay, all of them are present only when there is cricket class. In that situation, it can be equal to 1, but that is very unlikely, and it is like not guaranteed. Okay, so that is not really the answer. Then a few words that appear at the test time, so maybe ball, it can appear maybe multiple times in the test set. So again, that is also fine, right? Because maybe out of like say 500 words, if it is like appearing 2 times, you can say 2 by 500. So that is also fine, right? But the only issue is that uh, suppose we have a word that does not at all appear in the data. Suppose boundary is not present in the data. So how can we calculate the like probability here, probability of cricket given the boundary? Boundary is not present at all, so like that will be 0, right? P of boundary is 0, so the whole thing will become 0. So that is why we cannot calculate the because frequency is 0, the whole thing becomes 0. That is why it will be a problem that even if there is a single word that is happening at the test time that is not present in the training data, the whole thing will become 0. So that is the problem here. Okay, so what can be the solution here? So it is not practical, right? So you have data, it's fine, but in the testing time, whenever you are testing the model, there can be words that are not present in the training data, right? So just even if one word is not there, it can cause so much problem. So what could be the solution?
So here we can assign a very low probability of the words not present.
Yeah, right.
That overall it will not affect.
Yeah. So yeah, you are right. So basically, what we'll do is that smoothing. So that is one thing. Yeah, what you told that you can assign low probability. Then again, all the probability should add up to 1, right? So you have to kind of adjust that. So what we do is that smoothing means there are like many kind of smoothing. One of them is that, so this is kind of I'll show it in an example. Okay, so what does smoothing do? Suppose you have words like this, cricket, maybe cricket you have say 4 times, and maybe football you have 5 times, and maybe boundary you have 0. So smoothing is that we add 1 to everything. Okay, 4 plus 1 plus 1 plus 1. Okay, so probability of boundary will now be 1 divided by, so here total how many of them are there? 5. Here we are considering 6, and here even though there is 0 we are considering 1. So here also 1. So P of boundary will be 1 divided by 5 plus 6 plus 1, so it is 12. That. So this is kind of we can say advanced smoothing. Another thing is that we can assign epsilon to the P of boundary. Okay, epsilon, and even in that case, even though it will be very low probability, but it will not be 0. So that can also work. Okay, so and that is like applied for like very words that have 0 frequency. Okay, so here is a statement, two statement basically. So Bayesian networks always need to be DAGs, so directed acyclic graph. So is it true? This is first question. And second one is that each node in Bayesian network represents a random variable and each age represents a conditional dependence. So, is it true?
So option B, B for ball.
Uh,
One is true, two is false.
mhm. So, why do you think 2 is false?
Node will be a feature actually.
Mhm. Feature is kind of, we can say, random variable, right?
Uh,
So, if you formulate, suppose there are, let's say in that example only, this one, okay, this one is a feature, right? So, this one is a feature. Can you say this
yes,
is random
temperature,
variable?
humidity.
So, here like random variables actually mean feature here, okay. So, uh, run the option is actually true. So, basically whenever you are drawing a node, suppose the first one actually, okay. So, this is one feature, or like you can say random variable, okay, and then this is kind of dependent on a and b like this. So, uh, both the statements are true.
But how each age represents conditional dependence?
Yeah. So, C here the node C, okay, the random variable C is dependent upon B, right. So, again D is dependent upon B. So, it is C is conditional, C is also dependent upon A and B. So, they are showing dependence, right. They are representing dependency of C based on B, right. So, that is what we are mentioning here.
Not one, not understand.
Uh,
Can you please repeat?
Okay. So, here C is a variable, okay, like C is a node and C is dependent upon B and A. So, this node is representing that dependency of C upon B, right. So, what does this node represent here? Sorry, this edge. What does this edge represent here? C
Yeah,
is,
dependency of
yeah, C is dependent upon B, right. So, that is what we are mentioning. It is
yeah, yeah, got it.
yeah, yeah, edge represents dependency.
And one more thing, like what we can see that C is dependent on B when, like if how to formulate that statement that when something is given based on that condition, like these statements are given in the assignment, like when C is given like that question
Okay,
was there.
okay. Suppose C is given. Okay, here, can you say A is even independent of B? So suppose that is the question. Okay, so what will happen is that suppose we don't know the C. Okay, we don't know anything. Suppose what we do is that A and B they do not have any parents, and then we can say that they are independent. But suppose we know the C. Okay, so uh, if we know the C, then what will happen is that even though, even if we don't know A, we can get some information about A from C. Like, does it make sense? So, because you know C is coming from A and B, right? And if we know or do not know A, so consider it like this. Okay, consider it like this, that here E is not directly dependent upon A, okay, it is dependent upon C, but C is dependent upon A. So, it is indirectly dependent upon E is indirectly dependent upon A, right. So, uh, what will happen
So how to formulate that statement E is dependent on A given what we have to say?
is
given C,
Hmm.
like E is dependent on A given C, like that,
Hmm. Yeah,
or what to put on
yeah,
the given
yeah.
what? Okay.
So basically, how can you find the relation is that in that case, you do not need to consider that any, let's say, direction. Okay, so if I say that C is known, okay, then we can say that B is not independent of A, because like C is dependent upon A, so this forms a this kind of relation. So A is dependent upon say C, and from C we can know information about A. So this is kind of going this way. Okay, so it is A is reachable, like B is reachable from A, so that is why they are not independent, that kind of thing.
So B is not independent on A.
Yeah,
B is also depends on A
yeah, when C is known.
when C is given.
Yes,
Oh.
yeah, because from C, because C is dependent upon A, so you can get some information about A if you know the C. Does it make
And
sense?
if C is not given, then in that condition B is independent on A.
Yes, yeah,
Hello?
yeah, yeah. In that case, B is independent of A.
Yeah, okay, got it.
Okay, so
Sir,
yeah,
I think you have told opposite, no?
mm-hmm.
Because A and E are having a relation when we have a C.
Mm-hmm.
If C is not known, A and E are independent.
C is not known. Yeah, C is not known. Then yeah,
A and E are independent.
yes, right.
Yes, sir.
Yeah.
If A and B are there and C is known,
Mm-hmm.
then A and B are one level up, no? So they will be independent. It's like it will be ulta, no? Because three type of things it was told by the faculty. When both the arrows are coming to a single point, it
Mm-hmm.
will be opposite, not of the probability. Means not of the case.
Okay, okay, okay. Yeah, yeah, yeah. You here like both are children, right? So both are coming here. Okay, maybe not this graph. Okay,
Yes, sir. Because it should be
yeah,
ulta, ulta of.
yeah. So maybe CBD you can consider this part. Okay. So in case of B is known, C and D are not independent. That is what you are saying, right? Hello. Hello. Yeah. So yeah, in this case it is not the case actually, because both are yeah, because like both are kind of C is incoming edge, C is having incoming edges of A and B, but in this case if you consider uh, this is, so basically C and D have a, if you consider path in reverse direction, they are having a way to go from like a C to D, so they are like not really independent. Maybe I'll show you a different example, like with a little bit
Yes, sir, please,
complexity. Yeah,
please, sir.
yeah, yeah. Okay, I think there is something in your practice assignment today. Okay, I'll go there. Okay, so this is the options. Okay, so let's find out. At first is D is independent of B when C is known. So is it correct? Okay, A have multiple options, so let's check. A is here and C is here, okay, and E is here, okay. So is it dependent? There is a path, okay. So it is dependent. A independent of B, so that should be also be okay. When E is known, they are not really, they are dependent, okay, when E is known. So this option should not be correct. Okay, I am checking this. Yeah. So basically, what is happening here is that uh, when E is known, okay, so can you go from A to B? This, there is a path, right? So when you can go, like I am talking about the second option, okay, sorry, third option. Can you go from A to B without E? Yes, this you can. Similarly, from A to C, you can go, okay. D to B, can you go? Given C is known. So suppose you cross this node, okay. C is known, you cross this node. Can you go from D to B? No, you cannot. So that is independent, okay. A to B, can you go from A to B if C is not there? Suppose this is not there, can you go A here, but we are stopping here, C is not there, suppose we cannot go from A to B, right. So this is also independent. So A and B is independent when C is given, and so yeah, and D and B is also independent when C is given, okay.
Like what you are saying, that if it is independent, we can able to go or we don't able to go.
If it is independent, then we will not be able to go.
But if C is known, then we are able to go to D
Yes.
to D.
No.
So how it is
So
independent?
yeah. So you have to consider, so C is known, right? Here C is known. So
Okay.
we kind of
Yes.
cross the C. Consider C does not exist.
Yes.
So can you go D to B?
If if C is known, how? Like I'm not getting what
Yeah,
you're saying.
this is kind of like intuitively understand that how to calculate. So basically, what we are saying is that if C is known, okay, then uh, uh, so here D and B, okay, and if the C is known, then we cannot here if the C is known, then we cannot really reach D to B. So intuitively you can consider it like let me think a moment. C to B it is coming, okay. So so what is happening is that B is dependent upon C and D is also dependent upon C, okay. So uh, if we know B, okay, if we know C, we do not need B here. So similarly A to B, okay, A to B, right. So if this node is cut, C node is cut, we cannot reach from here to B, A to B. So that means like they are not connected. So that is why they are independent. But if they are connected, they are dependent. So because this arrow indicates dependency, right. So if there is no arrow, direct or indirect, that means they are independent.
And why that? Please, can you explain the other two option?
Okay. So A is independent of C. So A, C, okay, when E is known. Okay, so suppose E is known, so we are cutting this, right? Suppose E does not exist, still we can go from A to D and D to C. Like in this case, don't consider the arrows, okay? Like consider they are bidirectional, okay? For like when it is known, you have to consider this bidirectional. So A to D and D to C, or like A to D, C to D, whatever. Like there is a meeting point, right? There is a some connection from by connection from for reaching A to C via D, right? So this there is a dependency. So this is not correct. And again, if you check A to B, you can, there is again dependency, because if we just remove the E, then you can reach A to D, D to C, C to B. So there is a some path that connects A and B. So again, this is not independent.
Okay, got it.
Yeah.
Thank you.
So yeah, there are some week 7 questions. So should I answer? Like should I discuss these questions? Even though like there will be official answer solution in form of PDF in a few days. So like I hope like you understood the reasons of this question, like why these answers are correct. But yeah, let me just quickly discuss it briefly. So here like we have 4 options. At first, a model with lower training loss will perform better on test dataset. So this option is not necessarily true if the model is overfitting, right? So it can happen that we have very good loss during training but bad loss during testing. So this is not always true. Okay. Second one, train and test dataset should represent underlying distribution of the data. So this one is correct. So this is the basic assumption in all the models that we try to build. Okay, that train and test dataset should represent the underlying data distribution. Then to determine the variation in performance of a of a learning algorithm, we generally use only one training set and one test set. So that is clearly not correct, because suppose we are using different data split and then we are getting different results, that means we are having high variance. But if we are just using only one training set, one test set, so that means like variance there are like it is not ideal, because there might be high variance. If we just use a different data point, like different split, then the loss and everything will be hugely different. So this is not true. Okay. Then a learning algorithm can learn different parameter values if given different samples from the same distribution. So yeah, this is absolutely correct. I think you saw that in Perceptron also. So like if you give, even if you take from same distribution, but even if the order are different, then also it can have different parameters. So even if the data set are same but their order are different, then also it can have different. But if the data set itself are different, it can obviously have different weights, different parameters. Okay. Then we have data set 100 data from class A and 50 data from class B, and we have to find what is the best split. So basically it will be like see the ratio here 150, so it is like 2:1 ratio, right? So in the here also we should have 2:1 ratio. So it is 80-30, 20-20, so not really 20-20, so it is 1:1, 80-30, so it is not correct. 80-40, so it is 2:1, and 20-10, it is also 2:1. So this can be correct. 20-20, it is 2:1, again this is also 2:1, right? So this can also be correct. So which one of them should we take? We should take this one, train A80 B40, because train should ideally should have more data points, so the model can learn. Test set should have a little bit less, not very much less, but yeah, train set generally should have much more data set than test set. Then this option is also pretty straightforward. So in k-fold cross validation, uh, each class should have like if we are taking 5-fold cross validation, it is expected that in each of the fold we should have all the classes in similar proportion. Okay. So suppose yeah, that is the case actually. So it should not be that case that all the true classes are in the train set and like 4-fold, and in 1-fold there are only false classes. So that will not be ideal. Another thing is that in k-fold cross validation, we train one model and evaluate it on k different test set. So again, that is not really correct, because we in k-fold cross validation we train multiple models, right? And we train like we train multiple models and we evaluate on k different test set. So basically, we divide all the data we have into multiple parts, and then we kind of use k minus 1 part for training and 1 part for testing, right? For like each of like, and then we repeat it k times like that with different set. So this option is
One
not really
model
correct.
means one set, sir. One model means one set of data.
What?
One model means one set of data which we are dividing like one kth value.
One set of data. Yeah.
One model. What is a model means, sir?
Model
One
means
one
that
classifier, one
model means
classifier or one.
yeah, it means classifier. You can say
No, sir, but it is written we train one model and evaluate it on k different test sets, sir.
yes. So, but in k-fold, uh, yeah.
Sir, one see first is written train one model,
Hmm.
and finally it is written k different test sets, not
Yes.
test models.
Hmm. Right. So, what happens is that, so k different test set here means that we have say suppose for 5-fold cross validation. Okay, here this state means that we have 5 different test set. Okay, and we are evaluating on that. But what happens in k-fold cross validation is that we have a data, we are dividing that data into 5 folds, and then we are using these, then like 1 fold at a time, then this fold at a time. We don't have 5 different data set. We have only one data, and we are dividing them into 5 parts, and we are using them interchangeably. So it is not that we have 5 different test set and we are exclusively using that for testing. That is not the case, right? So okay, let me show what it is meaning here.
Hello, sir.
Yeah.
Yes.
Yeah.
Sir, for training the model, we need to go for the testing of the data, na? Not with the proportion of the data. Entire model, we don't need to check, na? We have to take some data sets like different data sets as it is mentioned in the option B.
Yeah, we have to take different. So okay, I'll show you with some example. So 5-fold cross validation. Okay, so this is fold 1, if 2, 3. So what happens in 5-fold is that at first we take this 4 data for training, okay, and this for testing. Okay, this is 1. Then we take maybe this 4 for training and this one for testing. This we repeat, but in this question it is saying that we have a test set. So this one another test set. So it is saying that test set 1, okay, this is test set 2, test set 3, test set 4, test set 4 and test set 5. So here in the question it is saying that we have,
Then, sir, it is the different set of data, na? 2, 3, 4, 5 you are taking.
yeah,
The different set of data for
different
the
set of
K.
data, yeah. But
Then how the answer will be K? Option A.
which one?
How the answer will be option A? You are telling K-fold cross validation. Each fold should have a class-wise proportion similar to the
Yeah,
given data set.
so yeah, this is what
It
question.
should be the different data set as per your writing.
No,
2,
no,
3,
no,
4,
no.
5.
I'm saying this for option B. Okay, option B is saying that. So which is incorrect, right? Option B is incorrect.
But in the answer you see word K-fold cross validation they are putting as this is only option A only correct they are
Yeah,
putting na.
option A is correct. So if you
But how, sir? Option A is correct.
okay, so consider this. This is fold 1, fold 2, fold 3. Okay, let me consider this. You have data for maybe diabetes. So true class are like say 200 and false class are say 100. Okay. So in this question they are saying that if that is the case, then in each class we should have 40 true and 20 false. Okay. So here also 40 to 20 false, here also, everywhere like class should be the same, similar, if not same. Otherwise there will be imbalance, right? Because if you just put everything to suppose true to this class, true, and this two false, then it will be like it will train on this 4 and it will be like imbalance. True class will be more, false class will be only here. So it will create a bias, right, towards one fold or another. So it will not be able to learn properly. Does it make sense?
No, sir. Can you explain again, sir?
Okay, so here suppose like it is mentioned that we should have class wise proportion similar to the given data set. So suppose we have a given data set with 200 example, 200 example with true level, 100 example with false level. Okay. Then what it is saying that in each fold we should have 40 true and 20 false. So suppose this is one distribution, okay, one distribution of K-fold. Okay, I'll show you. Another one, suppose here 40 true and we do not have 62, suppose 62, this is 62, so 50 true and 10 false. Suppose here maybe again 60 is 120, 50 170, 30 true and 30 false, and here say all of them are false. So in the question it is saying that in the training set the data like in the data set the ratio is 2:1, right? True is 200 and false is 100. So ratio is 200:100, that is 2:1. So it is saying that in each of the split the ratio should be maintained. So if we do this like this, so 60 true, 50 true, 10 false, so it will be like kind of imbalance, right? All of the folds are not equal class wise. Here the ratio is like 1 to infinity, like 1 to 0, 1 to 0, right? So like it is not balanced. That should not be the case. It should be balanced, like whatever there is in the data, each fold should contain similar proportion of the data. So that is what meant by the option. Is it
Okay,
clear?
sir.
Okay, so in the next, leave one out cross validation. So in that case, it is very similar to the k fold, but we just use instead of k fold, we just like remove one data set and use that for testing. So that is the no, that is not correct. Okay, you train you we train n different models, right, using n minus 1 data point, right, and use one data point for testing. Okay. This is not obviously not correct. We do not use same data to test everyone. So if we are using first example for one model, we will use another example for another model. So only first and third are correct. Here, again here like high recall. So recall formula, you know what is the recall formula? Recall formula is what is the formula? True positive divided by true positive plus false negative, right? So here where the recall would be low, so here this one is true positive and predicted negative is here and actual positive is here, so that is false negative, right? So we have to find the highest recall. So 4 divided by 4 by 6, so 4 divided by 10, that is 0.4, 8 divided by 8 plus 10 is 0.8, 5 divided by 5 plus 5, that is 0.5, and 2 divided by 2 plus 8, that is 0.2, right. So the correct option would be this one, 8, 2. We don't even have to consider these ones. Then again we have FPR, false positive rate. So what is the formula for false positive rate? Yeah, you can see from here. False positive rate, false positive plus false positive plus false positive divided by FP plus Tn, right. So what is the false positive here? This one is the false positive, right, predicted positive but actually negative. So this one is Fp and Fp divided by Fp plus Fn, F plus Tn. So true negative is what? This one, right. So which one is the highest? Which one is the lowest? 6 by 90, 13 by 90, 2 by 90, 4 by 90. So 2 by 90 is the lowest. So that will be the answer. Okay. This one is a little bit complicated. So basically you are taking a logistic regression. Yeah. So suppose in what we consider by default is threshold is 0.5. So above 0.5 is 1 and below 0.5 is 0. But suppose we are considering that threshold is 0.4. So in that case, what can we guarantee? So let's first check this one, false positive rate. Okay. So false positive rate, what is the formula? This one, right? false positive plus divided by false positive plus true negative. Okay. So what will happen if we increase the threshold? Sorry, if we decrease the threshold. Threshold was point like 0.5. If we are decreasing threshold, so many more examples will be classified as positive, right? So many more will be predicted positive, and what will happen then? If many more are predicted positive, then false positive rate will increase, right? So suppose you were only considering anything above 0.5 as true, but now you are considering anything above 0.4 as true. So it is likely that false positive will increase. So this whole value will increase, right? False positive rate will increase. There are chances of increasing. Yeah. Yeah. And like if the false positive is increasing, so what will happen to true negative? It might decrease, right? So what is happening here? So yeah, let's consider the confusion matrix. So initially there were some values. Now this is true class, this is predicted class. Okay. So suppose there are many predicted negative, but we are considering like we are classifying some of them to positive. Like there are some values with between 0.4 and 0.5. We are shifting them to the positive class, right? So true positive might increase, false positive might increase, false negative might decrease, they might decrease, right? So this part will increase and this part might decrease. So we cannot really say anything about like depending upon how much Tn will decrease. So FPR may or may not like it can go either way. Let's take another example. Okay. Okay. So yeah, so for theta equal to 0.4, FPR false positive rate. Okay. So so TP divided by FP divided by Tn plus FP. So false positive rate, false positive will increase. Okay, like false positive might increase, but Tn might decrease. So like that value can be. So initially when we are considering point right now like APR is 0.3, okay, and if we are lowering the if we are lowering the theta, okay, then much more values will be predicted 1, and it can like decrease the overall rate, because like this one Tn might like come down. So similarly, like you have to calculate like this for other examples also. So next question. So boosting takes multiple weak classifier and combine them into strong classifier, and boosting assign equal weights to prediction for all weak classifier, and this result in high overall performance. So first option is true, because that is the like basic idea of boosting, that you will have one model and another model will try to improve the mistakes of the previous model. So this is kind of a combination of multiple models. So that is correct. And boosting assign equal weights to prediction of all the weak classifiers. So that is not the case, right? So basically what happens is that first you have a model, then this tries to correctly classify the mistakes of the previous model and so on. So not all of them are having equal weightage. So right, because it is like dependent upon their how much they are performing and how much their misclassification is, that kind of thing. So this is not really true at all. This is not true. Let us know explanation. This is not a true statement at all. So this one is false. P is true and Q is false. Then this is about ensemble. So individual classifier in bagging cannot be trained parallelly. So in bagging, what happens is that there are multiple models and we combine them, right? We do not combine them sequentially, we combine them, just combine them, take the weighted average kind of thing. So they are basically independent upon each other. So we can train that parallelly, right? So bagging, there is no issue in training parallelly, but boosting, we are training one after another depending upon the mistakes of the other. So we cannot train the second one without training the first one. Similarly, we cannot train the third one without training the second one. So that is also not like that is correct, that we cannot train it parallelly. We have to do it sequentially. Commit of machine can contain different kind of classifier, which is true. So this is like it can have. It is not like that all of them should be similar kind. So that is correct. Then bagging further increases variance of an unstable classifier. So that is not really correct, because we are building multiple models, and what will happen is that if you are building multiple models and taking their average, then the variance will reduce, because if you are training only one model, then depending upon many things it might perform well, but on different model with similar technique or very slightly different data, it might perform very differently. But as you are considering bagging, so when you are combining this, the variance will reduce. So like this option is no, like this is it does not increase the variance, it decreases the variance. So this one is not correct. So these are the all the questions that we are supposed to discuss today. Okay. So anyone have any other question?
Sir, daily, like only Saturday, this session
ले
is
जाना,
going to
मोबाइल छोड़ ले
happen.
जा.
Hello.
Sir, sixth question and it's okay, sir.
Yeah,
Yeah,
like
no,
every
sorry.
Saturday or Sunday also.
Okay, no. So there are 3 sessions for this course. One is Saturday, another one is I think in Sunday, another one is in Tuesday. I think. So have you joined the Google group? So you can get all the information from there. So if you
So where is it?
okay, so
What's
Sir,
what?
yeah, you can go to Q&A. Okay, if you go to the
Okay.
Q&A, you can join the group, and then you will get emailed about like sessions. Another one is that you can go to the announcement also. Okay. Yeah. So
sir, sixth question have you explained?
yeah,
Sorry, I got
yeah.
disconnected.
One second. I'm just saying. 1 second. So yeah, you can find it here. Okay. So if you
Sir,
check this,
tomorrow also.
yeah, tomorrow also there should be one. So let me check Saturday. Okay. Just wait a second. Yeah, Sunday there is a session from 7 to 9. Okay.
Okay, so this question again or doubt will be going to sir.
Yeah. There will be some
Okay.
another person, so you can ask doubt there also.
Okay. And so please share the previous year that assignment.
Okay, so I will share the slide and it have everything, like including questions.
And that previous year you told no previous year.
Yeah, so these questions, many of the questions are from previous years only. Okay.
Okay, okay.
Yeah,
Okay, thank you.
yeah, okay.
Sir,
Yeah,
question number 6 have you explained, sir?
okay,
Sorry,
okay.
I just got
Let me,
disconnected.
let me.
Sir, week 7.
Yeah, yeah, excellent. Sorry. So yeah, there will be some official solution. Uh, we'll provide the PDF, but right now, oh yeah, question 6. So basically, here we are considering we have a logistic regression model, and initially the threshold was 0.5. Okay, and with 0.5, we have false positive rate of like 0.3. Okay, and if we are increasing, if we are making the threshold is 0.4, so if we are lowering the threshold, then what will happen? Much more examples will be marked as positive, right? So here we are considering more than 0.5 is 1, but now we are considering more than 0.4 is 1. So everything that were between 0.4 and 0.5, that will become 1 additionally, right? So what will happen is that true positive might increase, false positive might increase, true negative might decrease, and false negative might decrease. So if that happens, there are chances that false positive rate will go down, because like denominator is going down. Sorry, denominator. Sorry, uh, like numerator is going up, uh, but denominator is going up.
No, sir. Actually, when we have seen initially, also I asked a doubt in last class also.
Mm-hmm.
FPR and TPR both will be increasing when theta goes down,
Mm-hmm.
and FPR and this value will be decreasing when theta goes up. And that graph also I shared with some 4 web pages link also.
Mm-hmm.
So only option which is correct is B only. When theta is 0.4, FPR could be higher than 0.05.
Okay.
There is no relation, sir. Actually, if we see, if required, I'll share the links again.
Okay.
And nowhere in the means I have never got this answer like this is correct.
Okay.
Can you show where it is correct, sir?
Okay. Okay. Let me verify it once. Okay.
And twice I have posted in this forum, nobody has replied.
Okay. So can you say which one?
Yes, sir. Deepak Srivastav, sir. I have put.
Okay. Yeah, this one. Yeah, yeah, yeah. So yeah, they will provide a solution very soon, and then you can like challenge it. So there was yeah, you can like they will check it once, like by this only NOC 2451, and they will check it and like they will reply after some time.
No, sir. Whether you can understand
Yeah, yeah,
whether that options even are correct, I don't
yeah,
think
yeah.
so. So it is correct.
Okay, okay, okay. Let me check it again. Okay,
He also, yeah, this person also has shared the same doubt. Only option B should
okay,
be
okay,
correct.
okay, 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 okay. Let me draw and see. Let me
Okay,
go
okay,
to
sir.
detail. Okay. So we have a this, and basically we are trying like this. Okay, this is 1, this is 0, and suppose FPR is what? FP plus and FP plus TN. Okay, is there anything? Okay, okay, just I'm missing it here. Okay, suppose initially this one is 0.5, okay, 0.5 suppose, and now it is 0.4, 0.4. So if this portion previously it was 0, but now it is 1, right? So in this portion we will have uh, let's draw a diagram. Insert table, right? So
Sir, I've shared a link, sir.
yeah,
With
yeah,
that, I
yeah,
think
I'll
it will
just
be.
verify it myself. Actual,
Okay.
and then with this have predicted. We have 1 here, suppose 0 here, actual 1 and 0 here. So what will happen is that we are increasing prediction of 1, so it will increase, this will also increase, no sorry, yeah, actual can be anything, but our prediction we are increasing the number of prediction 1, and this will decrease, this will also decrease. Okay, so the formula is Tp divided by Tp plus Fn. So Tp, this one will increase, so numerator will increase, okay, denominator one part will increase and another part will decrease, this one, right, true negative. So so let's go to the picture. So this one is positive, like increasing, this one is increasing, and this one is decreasing. So can we okay, it can also happen that this is not increasing at all, that can also happen, right? It can also be equal, it can also be equal, but this can go down. So if it is going down, yeah, if it is becoming lower, numerator is becoming lower, in that case the whole value will increase, right? Yeah, so it cannot go to below 0.30, right? It cannot go below 30. So yeah, you are right, that option would not be correct, this one is not correct. Okay, yeah, correction is required here. Okay, so you have written to the email, so they will check the number. Yeah, it can go above 0.45. Must, I don't know, must cannot be correct. So opposite will happen for TPR rises, so 0.85, okay, 0.8 is there. So I think, yeah, we have to check it again. So yeah, this option is not correct, that is for sure, and that is correct, that is for sure. Then other needs to be verified. So you have written in the
Can you explain
I've,
once? Can
sir,
you
I've
explain
shared the link.
that?
what?
So,
Hello, can you explain once?
Yeah, so okay, so what we are
Sir,
doing,
if two
what,
options are there, like one you have higher than 0.3 and one is higher than 0.45, then which one we have to choose then?
uh,
Both are higher.
which options are there?
Means suppose in exam, or we have options like similar to this second option, one more option is there, higher than 0.3. Then which one to choose?
Yeah, that can also be correct, both you will choose.
Those.
It is multiple select, right? Yeah. So basically what I am saying here is that in the diagram, okay, yeah, here is the diagram. So this is the point threshold equal to 0.5, this is the threshold equal to 0.4, and you have some point in between. So initially if we consider 0.5 as the threshold, then these are 0, right? But if you are lower down the threshold to 0.4, these are becoming 1. So some part which were predicted 0 earlier is coming as 1. So if we consider this table, so we were predicting there were some numbers in this, but we are predicting those, like we are sending this to here. So, this will increase or remain equal, this will also increase or remain equal. This one decrease or equal, because we are shifting something from there. So, maybe it is possible that there are no values from 0 to like 0.4 to 0.5, that is also possible, right. So, in that case that will be equal, decrease or equal. Okay. So, this is the formula for false positive rate, right. So, false positive will increase or it will remain equal, this will increase or remain equal, and this will decrease or remain equal. So, if it is increasing and this is also increasing, but this value is positive, right, Tn is positive. So, suppose this is 5 by 12, suppose initially it is 5 divided by 5 plus 7, suppose, okay, and suppose one of them shifted to positive class, okay. So, it will be like 6 divided by 6 plus 6. So, initially it was 5 divided by 12, now it is 6 divided by 12. So, it is always increasing, right. So, if there is like shifting, it will either remain equal to 0.3 or it will increase, it can never go below like 0, it can never decrease from the initial rate, because numerator is increasing, denominator is increasing with that, and FP is okay. What will happen if Tn is decreasing but it is not increasing? So, suppose there is another scenario where true negative, there was true negative earlier, now it has been converted to true, okay, true negative cannot go to true positive, right.
So it become FP only, no, false positive
Yes.
only. True negative has been converted to false positive. That
Yes.
only got increased here.
Yes, because true negative cannot go to true positive because it is negative
No,
actually.
no, no.
So,
Yes,
it can
yes.
only go to true positive. So, in that case
Yeah.
FP will increase in numerator, FP will increase here in denominator, and this will decrease. So, ultimate value will go to the increasing direction, because numerator is increasing and this value is remaining the same, because if it is going away from here, it is coming here.
For TPR also it is the same relation only, sir. TPR also it will increase only.
Okay.
So you can just see that link it is given.
Yeah. So, I am just showing it for false one. You can just check for other. So, this is suppose 5. This is suppose let's say 7. This is suppose 10. This is suppose 3. So, basically predicted earlier it was predicted 0, this one. Now, we are predicting them only one of them we are predicting, let us say from here we are predicting one of them here 1, earlier it was 0, we are predicting 1. So, if you are predicting 1, what will happen? It will become 9 and it will become 6, right, because it is label is like 0. So, here it will be increase here, right, actually is 0 and label is 1, actually is 0 and predicted is 1. So, this one will increase. So, this is what predicted 1, actual 0. So, that is true positive. So, true positive will increase and false true, sorry, this is false positive and this is true negative, right. So, earlier it was how many true positives are there? 4 divided by 4 plus 10. So it was 3. Earlier it was 3, and now we have 4 divided by 4 plus 9, right? So basically 1 is coming to this side. So here also denominator is 13, here also denominator is 13, but numerator has been increased. So in whenever you are lowering the threshold, only numerator can increase. It may or may not increase, but there is chances of increasing. Okay, so it cannot really go below 0.30. So that is not really correct. It cannot be lower than 2.5. It can go above 0.3. It may not go. It may or may not go, but there are chances that it can go 0.30, 0.35, 0.90, whatever. There are chances that it can go. So you can say that. So yeah, okay, then I think like this will be replied by the admin. So please wait till that time.
Okay, sir.
Yeah. So I am ending the session then. Thank you very much for joining.
Okay, sir. Thank you, sir.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you, sir.